Hello all, I'm Siddharth Kaul and I welcome you to Edupedia world. In this video, we are going to take a look into function files in Matlab. I'll give you a small demo about how to create a function, how to save a function, and how to call the same function. So I'm going to create a new function by going to File, New, and I'm going to select a function. So Matlab automatically generates some code for a function untitled. So here in this case, as this is my second attempt, so it is an untitled 2. So for any function, there is an output argument, that is output argument, and there is an input argument. So let me define the output argument as out, and let me name the function as sample function, and I will take input only one, that is input argument only one as input underscore one. We can add the help for the same sample function here in the first two lines. So I'm just going to write it's a sample function, and I'm going to write a summary as my first function. Now let's do something with this input. So I'm going to just assign to the output a square of input. So input 1 into input 1. So this is some random line expression I wrote. Similarly, we can write anything here. So I'm going to save this function. So I'm going to save this in my current path as sample function.m. So the point to note here is the name of the function and the file of the function should remain the same. So I'm going to save this, then I'm going to close this, and I'm going to call the sample function and pass an argument of 5. So I get a 25 here. So this is how we call a function. So the point here to note is that the sample function is currently in my current folder path, and hence I can call it directly and pass the argument here. Matlab allows us to add help text as we see in the built-in function in our custom function. So help text is the first two lines that I was talking about in the demo. So the help text is something that appears in command window when we use the help function. We create help text by inserting comments at the beginning of our program. We position the help text immediately below the function definition line, the line in which the function keyword is used. So for example, here I have created a function in a file named addme.m that includes the help text. The first help text line, often called the h1 line, typically includes the program name and a brief description. The current folder browser and the help and look for function use this h1 line to display the information about the program. We can create see also links by including the function names at the end of our help text on a line that begins with a percentage. Like see also, like when we ask for help from Matlab, it suggests us some see also functions, like something we should also see. So if the function exists on the search path or is in the current folder, the help command displays each of these function names as a hyperlink to its helps. Otherwise, help prints the function names as they appear in the help text. We can include the hyperlinks that redirect to some certain website or certain references in the help text. These are created in the same way as they are created in the HTML. This is created using an anchor element. As it is pretty basic, so I'm not going to cover it here. Now let's talk about workspaces. So there is a difference between the base workspace and the function workspace. The base workspace stores variables that we create at the command line. This includes any variable that script creates, assuming that we run the script from the command line or from the editor. The variables in the base workspace exist until we clear them or we end our current Matlab session. But functions do not use this base workspace. Each and every function has its own function workspace. Each function workspace is separate from the base workspace and all other workspaces to protect the integrity of the data. Even local functions in a common file have their own workspaces. Variables specific to a function workspace are called local variables. Typically, local variables do not remain in memory from one function call to the next. So when we call a script from a function, the script uses the function workspace. Like local functions, nested functions have their own workspaces. However, these workspaces are unique in two significant ways. The first one being nested functions can access and modify variables in the workspace of the functions that contain them. Second is all of the variables in the nested functions or the functions that contain them must be explicitly defined. This is, we cannot call a function or a script that assigns a value or to variables unless those variables already exist in the function workspace. Now the obvious question arises is like how to share the data between these workspaces. So there are multiple ways in which data can be shared between workspaces. In most cases, variables created within a function are local variables known only to that function. So local variables are not actually available at the command line, or it is not available to any other function calling this function. So there are multiple ways we can extend the scope of these functions. So the most secure way to extend the scope of a function variable is to use function input and output arguments. So this legally allows us to pass the values to the function and take the values from the function. Let's take an example. Here we have created two functions, update1 and update2, that share and modify an input value. Now update2, a function that has been called in update1, and this can be a local function inside update1, or we can have it as a separate file. Here in this case it is a separate function. So the last three lines are the one that has been typed in the command window. So these calls the function update1 and pass the vector x. See, the data defined in the workspace, that is x, is passed first to update1, and then inside update1 this same x is passed to the second function, that is update2. And the data is calculated by the update2 is first passed to update1 and then back to the command line in the Matlab workspace. A nested function has the access to the workspace of all functions in which it is nested. So this is also one of the way where we share data between functions. So for example, a nested function can use a variable, in this case as shown here, x, that is defined in its parent function. So this is the example on the left. So we have a primary fx, that is a primary function fx, where we have x equal to 1, and then we call the nested function nested fx. This nested function nested fx is defined with x equal to x plus 1. When parent function do not use a given variable, the variable remains local to the nested function. So for example, for the similar example to this, the right version of primary fx we will see. So on the right hand side we have again the function primary fx. Inside it we have two nested functions, that is nested fx1 and nested fx2. So in the nested fx1 we have x equal to 1 and we have x equal to 2. So these both have their own versions of x. So these are nowhere linked to the primary fx and these cannot interact with each other. So this is like one of the differences between the nested function as shown on the left and the nested function shown on the right. On the left we have a variable in the primary function itself and the nested function is using it. Whereas on the right we do not have a variable in the primary function and nested function are using their own independent variables that basically cannot interact with each other. Another way of sharing data is using persistent variable. A persistent variable is something that retains its value from one function call to the next function call. Other local variables retain their value only during the current execution of a function. So these persistent variables are something equivalent on the lines of static variables in other programming languages. For example, we define a function in a file named findsum.m that initializes a sum to 0 and then adds to the value on each iteration. When we call the function, the value of sum underscore x persists between the subsequent executions. So basically we are here calculating that how many times the find sum has been called. So this is like one of the examples of how to use these persistent variables. Global variables are another way we pass data between the workspaces. Global variables are variables that we can access from multiple functions or even from the command line. They have their own workspace which is separate from the base and the function workspaces. However, global variables carry extreme high risks. Say, for example, basically any function can access and update a global variable. Other functions that use a variable might get unexpected results. So if we unintentionally give a new global variable the same name as an existing global variable, so one function can override the values expected by the another. This error is very difficult to diagnose, so it is recommended to use global variables sparingly if at all. We declare global variables using the global keyword. This declaration is necessary before we access them within any particular location. This location can be in any function or through command line. For example, here we created a function falling that takes time vector t and returns the height h. This uses a gravity constant which is a global variable. This value is taken from the base workspace which can be updated by anyone. A usage has been shown below that again first declares gravity as a global variable to let Matlab know that we are referring to the global variable, and then it assigns a value of 32. And then we make a call to our function. We have talked a lot about anonymous function in the previous videos multiple times. Let's revisit it. So we all know that anonymous function is a function that is not stored in a program file, but is associated with a variable whose data type is function handle. Anonymous function can accept inputs and return output just as a standard function do. However, these anonymous function contains only a single executable statement. A very simple example is shown here where sqr is a function handle for an anonymous function that takes input x and returns the square of x. Let's test it. So we call the function handle sqr and pass the argument 5 to get 25 in return. Function handles are capable for storing not only expression but also variables that are used in the expression. For example, here I have created an anonymous function with function handle parabola that uses a variable a, b and c to manipulate input x. Now as a, b and c are available at time I have created the parabola available at the time when I created the parabola, the function handle will include these values. So these values will basically persist even when we clear the variables. Now in the second segment I have cleared the variables a, b and c and still the function works because the function handle parabola has along with the function statement has stored the values for a, b and c. Now to supply a different values of a, b and c we need to redo and redefine the function handle. An anonymous function can have multiple anonymous functions called inside it. This is useful for passing different parameters to a function that we are trying to evaluate over a range of values. Let's take an example. Let's take a very simple integration problem. Take the equation x squared plus cx plus 1 that is being integrated over 0 to 1. For the same, the multiple anonymous function is written as g. This g contains multiple anonymous functions. The first anonymous function is where we write the integral function, that is the x squared plus cx plus 1, in which we pass the value of x. Then we evaluate this function from 0 to 1 by passing the function handle to the integral function integral and passing the values of 0 and 1. The second anonymous function is where we supply c. So c is the input argument for the second anonymous function that takes this whole thing as its expression. Anonymous function does not necessarily need to have an input argument. There may be some cases where we don't require an anonymous function to have input arguments. Like here we have an anonymous function that returns the current date and time without taking any inputs. So such functions are called with the function handle and empty parenthesis as shown in the second line, where we call the function handle t with empty parenthesis. Now point to remember here is that when we don't use empty parentheses, we are just creating a new function handle. As shown in the last line, we wrote d is equal to t without any parentheses. This just created a new function handle d and did not execute the anonymous function. Now anonymous function can have multiple inputs and multiple outputs. Anonymous function requires definition for input arguments in the same way as a standard function would require. Here I have shown an example where it takes more than one input, that is x and y. As seen from the first line, it is very similar to that of the standard function. So here the my function handle has an anonymous function that takes in two input arguments x and y and evaluates with the expression x squared plus y squared plus xy. This whole expression returns a single value. So we will test it out. So we pass x as 1 and y as 10 and we call this function, so we get z as 111. But there is a slight difference in case of output arguments. We do not explicitly define output arguments when we create an anonymous function. In case an expression in the function returns multiple outputs, then we can request it when we call the anonymous function. We enclose these multiple output variables in square brackets. Here for an example, consider the ngrid function that returns number of outputs as the number of inputs. That generates the number of output as there are inputs. So for two inputs, it will generate a two outputs. So here for two inputs, it returns two outputs that we can take using square brackets. So square brackets, basically it's called like x comma y, and we call our anonymous function. So these two outputs are stored in x and y respectively. Function handle, being one of the fundamental types of Matlab, actually does not support, or well, we can say it cannot handle more than one value. It works with only single elements. So what if we require to have an array of anonymous function? So what will we do in that case? In cases where arrays of anonymous function is required, the most common approach is to use a cell array to store the anonymous function. These are written as follows. We define a cell array f that takes the first anonymous function, that is the function x square, then the second as y plus 10, and the third as x square plus y plus 10. The point to remember is that we make sure the parentheses are used to ensure proper readability, and moreover the use of space can mislead Matlab into interpreting it as a separation command, which can in turn lead to errors. Now these handles are now accessed with referencing through curly braces, as f of curly braces 1 returns the first handle and f of curly braces 2 returns the second handle. Now to pass the input arguments, we use parentheses after the curly braces. So in case we have to call the first function handle, we will use f curly braces 1, and inside parentheses we will pass the input argument of x. Similarly for 2 we will say f curly braces of 2 and pass the input argument of y. Similarly for 3 we will use f curly braces of 3 and pass the two input arguments, that is x and y. The answer for same will be returned as the single value. Function precedence order. So this topic just covers the inner working of how Matlab, or like more accurately in which order Matlab calls a function having the same name in the current scope. This is just for information purpose, as it is good to know what order Matlab executes the function. The highest priority is given to variables. So before assuming that a name matches a function, Matlab checks for a variable with that name in the current workspace. That is why it is recommended not to have function with the same name as that of variable. Then comes the imported package function. A package function is associated with a particular folder. So when we import a package using the import function, it has precedence over all other functions with the same name. Then Matlab goes and looks for nested function within the current function. Then it moves on to the local functions within the current file. Then Matlab moves to the private functions. These are the functions in a subfolder named private that is immediately below the folder of currently running file. Then it moves to object functions. Object functions are something that accepts only a particular class of objects in its input argument list. In case we have multiple object functions with same name, then the distinguishing is done based on the input arguments. Say we created a class folder @function and a constructor function as function.m. Inside this @function / function.m, then this constructor takes the precedence over the other function named function.m anywhere in the path. Then continuing with the list, we have loaded Simulink models that are followed by the function in the current folder, and at last Matlab looks for functions elsewhere on the path in the order of appearance. This concludes our video on function basic. In the next video, we are going to take a look into function arguments. These are the variables that we pass to the functions. So until then, please subscribe and thanks for watching.